of design of steel structure presented by Rebekhal, Assistant Professor Civil, PSN College of Engineering and Technology. So first of all, what is the steel structures? So steel, what is mean by steel? The steel is a content of iron, is coming from iron ore, is a chemical content of carbon, silicon, phosphorus and sulfur and oxygen. So the percentage of carbon, the steel are defined as types of steels are maintained. So less than 2% of carbon is normally used for building constructions. Normally the steel having the carbon content, the percentage of carbon is very, very important for steel production. So the amount of carbon is present in the range of 0.0% to 2.14%, and the presence of magnesium is around 1%. The density of steel, density of steel means the common constant is 7850. Between the range you take that 7700 and 8050 kg per meter cube. The presence of carbon is a very, very important role for the steel member and is containing a molecular structure. The carbon is maintained for the all ductility and the strength is tensile strength also considered for the carbon percentage of steel. Normally the steel having carbon, silicon, phosphorus, the common role is carbon is containing for all the structure. So this is the manufacturing process of steel. So manufacturing process of steel means first the iron ore, the rock ore, iron ore is scrapped. The small amount of scrap is going to the electric furnace. The oxygen is induced on the electric furnace. The heat is produced. The oxygen induced to the scrap member and continuous scattering and fillet is going to the reheat the furnace, and rolling mill is create the number of lost cooling bed to create the bars, eye members, angle members, bar members also created for each one of the structure is used for construction of steel structures. So these are the manufacturing process. So first iron ore is the main source. The iron ore is the scrap content. The scrap content is going to the furnace and heat the iron ore. Release the oxygens are induced to the iron ore member and continuous heating and cooling bed to produce the bars, I section, L section of steel bars are produced and it is going to the market. The market having the number of steel section is the steel processing unit. Okay. So the types of steel section used for normally construction. This is the T bar. First one is T bar, T section. T section having the member of Indian standard TB. So T section having the consist of four method: wide beam, Indian standard wide, Indian standard medium, Indian standard heavy beam and Indian standard light beam. So ISLT, ISHT, ISMP. These are the steel. IS 800 2007 having the four types of T bars are produced. So this is the T bar section. Next angle section. Angle means L section. So L section having the two types: equal angle, unequal angle. Equal angle means the height and breadth are equal. So 90 into 90. The thickness only changes 10 mm, 8 mm. So this is the angle section. Angle section having two types: equal and unequal. Equal angle means the length and height are same. 90-90. ISA, Indian standard A angle. So ISA equal angle, ISA unequal angle. Next one is this is the blanch for wide blanch, I section. So I section is only used for construction, mainly used for I section for act as a column and act as a beam. So I section is very, very important, rolled up I section. This also consists of four different category. Wide one, the flange is wide means wide beam section, Indian standard wide beam, ISWB. Next, Indian standard heavy. The load of heavy means the density of heavy means it is defined as the heavy beam structure. Light, the density, the weight are very, very low means light beam. ISLB, ISHB, ISW means wide beam. So these are the different categories of the I section. Okay, so this is the I section. I section is normally defined as the flange are very wide, mean this is the wide I section. So this is a normal I section, this is the wide I section. Next is C section. C section means channel. So channel section means same also the beam structure. It is also consist of a light, heavy, medium, wide. The 4 categories are considered for Indian Standard Code Book IS 800 2007. So these are the types of steel section used for the workshop building or any type of railway platform. Next the workshop another 4th frame structure is used the I-beam and channel section. Normally L section is also used for the okay. So these are the types of steel normally consist of the market. Next the steel having the properties. Properties means it is the strength consideration, tensile strength, ductility, durability, conductivity and malleability. So tensile strength already you know that the bending strength of the steel member. The steels are having FE 410 normally used for FE 410. So 410 is the steel strength, plate strength, the I section strength also 410 or angle section having the strength of the 410 tensile strength is normally considered for steel member. Next the bolt are induced to the steel member, the bolt having different types of strength. It is based on your grade. The bolt having the grade of 4.6, 4.8 or normally consist of 4.6 is used in our IS 800 2007 code book. So in your code book you take a table, page number 18, you take the table and read the bolt strength. This is normally 400. The grade 4.6 means normally bolt strength is 400 MPa or 400 Newton per mm square. This is the tensile strength of the steel members. This is an example. Okay. So next one is ductility. So first one is tensile strength. Tensile is the amount of stress undergo deforming structurally. So tensile strength is very high means it is highly resistant to the fracture. So it is a main thing is tensile strength. Next tensile strength example is the plate having Fe 410 means the strength of 410 Newton per mm square. The bolt also having the tensile strength. The bolt and plate are connected to the member is the section going to the steel structure. Okay, so bolt also having the grade 4.6, 4.8. This is in your IS 800 code book. You take the value of FUB. Next properties is ductility. Ductility means there is a mechanical properties no change to the element change shape upon the application without fracture. The shape of the sections are changing, so without fracture is going to the ductility. So this is the main mechanical properties of the steel. Next one is very important, durability. So durability is dependent upon the carbon presence. The low percentage of carbon having high strength, it's highly resistant to tear and wear also. It is high durable material having the less percentage of carbon having high durability. Next one is malleability. Malleability means the member, compression member, so compression member means stud. The big members is considered to the sheet bar is allow the malleability. So this is going to the malleability. The steel member, compression member, column member is converted into sheet member is going to the rolling or any other process hammering is the malleability. So these are the 5 types of properties of steels. Tensile strength is the bending strength. Ductility is also resist the fracture. Durability is very important. It consists of the carbon content. Conductivity steel having the very heat conductive is used for normally domestic purpose, kitchen purposes. The material is used for conductivity purpose. You use that for domestic purpose. Next one is malleability. Malleability is also the compression members is converted into sheet member. So this is the malleability processes. So it is very important, the properties of steel. Next one is different types of steel based on your carbon content. So the carbon steel alloy steels are maximum used for construction. The carbon steel is carbon steel means I section, angle section, channel section. These are used to form the railway platform and the steel structure platform. So this is used for only less than 2% carbon content. A small amount of magnesium, sulfur, silicon and phosphorus. Next type of steel is alloy steel. So alloy is also type of carbon. It consists of carbon and more than used for magnesium and other material is used, other elements is used to for this purpose is the alloy steel. Okay, so these are the types of steel. Next going to tensile steel. Tensile steel is also rust resistant steel. So invented in England is 1913. So next chromium. Chromium is a very important material, is used for the tensile steel. The chromium is the oxidation resistant. So it is an anti-rust material, is used for kitchen purposes. Next, this is the carbon steel and the normally market available carbon steel. Bar. This is the bar member, tube structure, bar structures is normally used for small purposes. So these are the types of steel based on the carbon. Next one is structure. Based on your structure, these are the types. First one is portal frame structure. Second one is multi-story steel frame structure, steel truss structure, face frame structure, light steel frame structure, cable stayed or tension structure. These are the based on your steel structures. So first one is portal frame. Portal frame means the beam and column. Column also known as stud member. The stud and beam is connected to rigidly. This resists the moment resisting framework. Framework is the normally beam and column connection, is normally used for workshop building. So portal frame structure is used for workshop building, industrial building, low rise. The only very low height means use that portal frame structure. Next, floor area is very large means is used go for portable frame structure. It is example for warehouse, workshop, aircraft hangars. These are the examples of portal frame structure. This one is portal frame structures. These are the column members. These are the beam member connected. No interior supports is used. Only the floor structure is very lengthy. Only used for beam and column connection. This is normally workshop and warehouse building. This is an example of the portal frame structure. Next one is multi-story steel frame structure. Multi-story means the column and beams are is used for vertically skeleton framework. It is normally used for high-rise building, adaptable high-rise building. It is a complex urban building also used for that multi-story frame structure. So this type of structure also having the vertical column and horizontal beam also is a making a skeleton framework. It is support a floor. The portal frame structure is not support a floor, only the long length only used normally workshop, only beam and column connector. Multi-story means support a floor level. Support a floor level one by one is having a high-rise building used to do the multi-story steel frame structure. Okay. So next one is truss structure. Truss means also used for purling. So purling, the bridge structure is going to made up of slender beam, slender column is used. So triangulated steel members is used from slender member joined at the node. Joined at the node means pitch. So the tip connection also is connected together. The tension and compressions is induced on the member. It is a long span structure. It's normally used, minimal use only. So this is the stress member. So stress member means the triangulated member is used for the connection. This triangulated member used to connection. This is a minimal use for the purpose for steel member. Next one is space frame structure. So space frame is a three-dimensional structural members, interconnected stud also known as column. The column is arranged in the geometric grid. The stresses, face frame structure and multiple directions ideal for open areas, minimum support. So this is the face frame structure examples. Face frame structure means three-dimensional connections. Airport hangers is used for this purpose. Next one is light steel frame structure. Light steel frame is very light weight. The weight is very low, so it is known as light steel frame structure. Especially used for weight low means it's normally used for low-rise building. So modular prefabrication structure used for low weight. The weight is very low means you go for light steel frame structures. So this is the light frame structure. The density is very low. The heavy load is not acted. Only the load is minimum means go for that light frame structure. So these are the 5 types of steel structures. Structure means is the formation of beam and columns connected together is giving a one structure. So these are the 6 types of structure is used normally for steel members. Only using steel member connected to any connection. Connection having 3 types, bolted, riveted, is coming from another one. So these are the types of steel structure. So next, connection is very important. So in steel member means normally thinks that I-beam, channel section, bar and angle section. So the beam and column connection is using that bolt or riveted or welded is going for steel connection. The 3 types of connections is normally used. First one is very important, one is bolted connection. Second one is welded. Third one is riveted. So bolt is the important ones. It is a minimal requirement and also it is a easy to dismantle for temporary structure. So go for bolted connection. Bolted connection is more advantage compared to the welded and riveted. So rivet is not used for recent years. So riveted means it is one metal pins is inserted. This is the noise created ones, and also the metal pins also used to instructed the labor. The skilled labors are required. So the recent years is not used for riveted. The reason is going to bolted. Bolted is the cost is very low. Also compared to is very giving strength also compared to welded and riveted. And the easy to dismantle for temporary structure using the bolted connection. Next, welded. Welded means a heat are induced to, and heat are induced after that the connections make for that plate and the steel member. So second one is welded. Welded also produce the heat, so it is a disadvantage one compared to the bolted. The bolted is only used for labor, also not required in skilled labor. Only labor cost is very low. And it is not used in mechanical instrument, not using only. The hole is induced, then bolt and nut are induced to the member, is connected the member, and strength also increasing. So this is the bolted connection. Is the reason here bolted connection is very used one. Riveted is not using. Riveted means the noise polluted one, and also pin or inducted to the member is a high skilled labor is wanted, so reject the riveted connection. So bolt connection is very important. So next go for the bolted connection. So bolted connection means these are the member. So member connected to the cassette plate. The web bongles, the bolt are connected to this. So these are the sand. This is the bolt. The member of the bolt, the sand connection. So plain section is known as shank. Next, this is one is threaded. So threaded connection. Washer is known as the thread area, shank area. This is the head one. The nut are inserted, the strength are induced. So this is the thread length, this is the grip length. So these are the parts of the bolt. Bolt having 2 types: bearing bolt, high strength friction bolt. So this one is bearing. Bearing strength is induced to the member, so bearing bolt. Next one is high friction bolt. Friction bolt also using the thread is very high. Shank is only low height. This also shank is low, thread is low, shank is high. So these are the 2 types of bolt are used for the construction. So next one is riveted connections. So riveted connections are full detail. Riveted connection, this is also head. This member is shank, this member is tail. So this over the metal pin injected, the skilled labors are wanted. So riveted. The lap joint, butt joint. The joint having two types. First one is lap, second one is butt. Lap means the plates, two plates are connected one by one. This is known as lap joint. Butt joint means the horizontally connected the two member, and the rivet is, the packing plate is used, remember. So this is the riveted one. So first one is bolted connections. The bolted connection is very important one. This is the shank area. This is shank area. The plain area is a shank area. The thread area is one is used to connection for the net. Normally the diameter of bolt is used for 20 mm. First the hole is inserted, after that bolt are inserted. The hole diameter is plus 2 mm consideration for your code book IS 800 2007. Follow the IS 800 2007 code book. The assumptions are made that after that the procedure going for that diameter 20 means the only plus 2 mm is considered for hole. So 20 diameter means 22 is the hole diameters. Next, shank area. Shank area means AS. Thread area means AN. So N. Net area. Net area is the thread area. Shank area is the overall area. So it is used for the bolted connection member. Riveted connection is this type. This is the riveted one. So metal pin is used. The riveter. The joint having two types normally. Lap joint, butt joint. Lap joint means the plate was one by one connected to above, below one, above one is connected. The laps are recorded, so this is the lap. Butt joint means the member is horizontally connected to two member using the rivet or bolt or any connection is used to the butt joint. So next, the plate connected to the bolt member. These are the strength are induced to the bolted. Next, the plate strength also induced. The bolt having shear capacity and bearing capacity. The plate having yield, rupture, black shear. These are the failure strength also consider. Okay, so resist the yielding, resist the rupture, resist the black shear means is go for the strength is calculated after resist the yielding, rupture, black shear is based on the IS 800 2007. So first one is capacity. So shear capacity is very important. The bolt is connected to the member. The break the bolt. The bolt are break. The one bolt break to two members means the failures, shear failures are occurred. So to resist the shear failure, first you calculated the shear capacity of bolt based on your IS 800 2007. Next one is bearing capacity. Bearing capacity means the bolt are connected to the member means the bolt are bended or any one of the bolt are bending is bending failure. So bending failure means resist the bending, you go for calculated the bearing capacity of bolt. These are the bolt strength. Normally IS 800 2007 page number 75 having the shearing capacity, bearing capacity formula is resist the shear failure and bearing failure. Shear failure means the bolt has break. The one bolt break to the cut to two members means the steel structure is collapsed, the steel members is break down. So this is the shear failure. So to resist the shear failure, you determine the capacity. Shear capacity means shear strength. To determine the, before that you determine the shear capacity, after the resist the failure. So this is a very important for bolted. Next one is bearing capacity. Bearing capacity also the bolt failure. The bolt are bended or any one direction as going to failure occur means determine the capacity is resist the bearing failure. So these are the bolt related steps. Second one is the plate and bolt is a joint. The joint means the plate and bolted are connection. The joint is occur. So the plate having the three types of failure. The yielding, rupture, black shear. So resist the three types of failure. You go for calculated the yielding strength, rupture and black shear. It's a consideration for your IS 800 2007. The plate strength is normally, the page number is 32 in IS 800 4007. Formulas are arranged in IS 800 2007. The shear capacity and bear capacity is considered for page number 75 in our IS 800 2007 code book. You refer the code book and take that formula and calculate the shear capacity and also consider the efficiency of soil. The two plate strength and bolt strength are calculated. After that, the joint efficiency is must calculated. The joint efficiency means the strength of bolt divided by strength of plate into 100%. So this is the efficiency. The efficiency is very important for the connection. So these are the bolted connection strength. Okay. So next one, shear capacity. Shear capacity is based on your IS 800 2007 page number 75. This formulas are here. So FUB. So VNSP. Normally VNSP is the nominal strength. VDSP first calculated. VDSP means nominal strength divided by safety factor. So safety factor is denoted as comma MP. The steel having the safety factor for bolt having 1.25. So gamma MP value 1.25. We take in your code book IS 800 2007 page number 30 based on your type of bolt. The bearing fold means you take the 1.25. The shop bolt means taking the 1.1. So this is the based on your bolt requirement. We take for the fascia safety factor using the page number 30 in our IS 800 2007 code book. So this is the nominal shear strength formula. The formula is Fu divided by root 3 Nn ANB plus Ns ASB. So nominal shear strength first calculated. After that is divided by the fascia safety factor as a design strength is calculated. Okay, ma'am. So first one is Fu. Fu means the bolt strength. The given data, the bolt grade are used. The grade 4.6, 4.8 are given in your question. You take the page number 18 in your IS 800 code book. Take the FUB. FU means bolt strength. Normally taken as grade 4.6. The value is 400. 400 MPa is taken for FU. So root 3 into Nn. Nn equal to number of bolt in shear plane and the number of bolt in shank area. Net area. So Nn is equal to number of bolt used for one plane. Okay, ASP. ASP means shank area. ANB means net area. Net area is the whole area. The bolt is having the circular. So circular means what is the formula for area? Pi by 4 d square. So ANB is pi by 4 d square. ASP means shank area. Shank area is thread area is going to 5 by 4 d square. Shank area is 0.78 pi by 4 d square. So 0.78 consideration is the diameter of hole is normally 22. The diameter of hole is 20 and the hole diameter is plus 2 mm is taken. So 22. So 100 minus 22, 78. So divided by 100 means 0.78. So this is the percentage of thread section. You take that the ratio 0.78 5 by 4 d square. So shank area is plain area. So totally taken 5 by 4 d square. The thread area portion is only for threaded. So is minimize the bolt area 22 mm. So 100 minus 22 78. So 0.78 5 by 4 d squared is the shank area. So these are the taken for the area consideration. So this is the nominal shear strength. First nominal shear strength is calculated. After divided by the fascia safety factor, you get the design shear strength. This is the procedure for calculation of shear capacity of bolt based on IS 800 2007. So VNSB is the nominal shear strength. FUB is the bolt strength. This is normally taken. Bolt having the grade 4.6. Grade is, as example is grade 4.6 means you take the 400 MPa. So Nn is the number of bolt. A and B is the area of the net area. Net area means the shank area is normally taken 554 d squared. Ns is also number of bolt in shank area. So number of bolt is normally row wise arranged or zigzag connection bolt are connected. Next ASB is the 0.78. 0.78, how to take in the 0.78 means the whole area is 100 minus the whole area 22. 100 minus 22 is 78%. So 0.78 into 554 d square to be taken for this purpose. So these are the shear capacity of bolt consideration. Next one is bearing capacity. So bearing capacity is very important. This is also page number 75 IS 800 2007. So bearing, what is the bearing failure mean? The bolt or bended, any one section the bolts are bended means the section, steel section is collapsed. Shearing failure means one bolt is cut into the two or break down the bolt is the shear failure. So you resist the shear failure, must you take action with the shear capacity. The next one is bearing failure. Bearing failure also taken in your bolt connection. So the bolt is or bended or any one bolt shapes or changes means is going to the resist the bearing failure. First you calculated the bearing capacity. So nominal means it is not applied for the safety factor. Only the bolt taken permissible bolt distance. So this is the formula is 2.5 kb d small d into fu. So kb is the reduction factor. So reduction factor is also calculated based on your IS 800 2007. The below 4 values are given in your code book. E by 3 d naught, comma p by 3 d naught minus 0.25. FUB divided by FU, comma 1. So the 4 value first calculated, which one is minimum, you take the KB reduction factor. Okay, so first KB E by 3 naught. What is mean by E? So E is the end distance. End distance means the bolt are connected, the plate, the last portion to first bolt portion is taken as the end distance. The end distance is normally taken 30 mm, 40 mm is normally assumed that. So E equal to 30 or 40 taken, and 3 D naught. D means bolt diameter. What is the D naught? D naught is the plus 2 mm added for your code book procedure. So 22 mm. So D naught is the 22. E is normally is the end distance, last portion of the bolt connection member. So taken normally 30 mm or 40 mm. The formula also using that based on your diameter. 1.5 into D is used for E. Pitch, next P by 3D naught. P means pitch. What is mean by pitch? The pitch is the center to center distance between the two bolt. Horizontal distance between center of two bolt is known as the pitch. So pitch is normally, you don't have any given data means you take that 2.5 into D naught. D naught is not normally you know that 22 mm. 22 into 2.5 you take the pitch. So P by 3D naught minus 0.25. Next FUB. UB means ultimate strength of the bolt divided by FU means plate strength, the plate or tensile strength. So comma 1. So 4 values, which one is minimum, you take that reduction factor KB. Next one is D. D is diameter of the bolt. Normally diameter of was M20 given in your M20. M means the bolt diameter, you take that M not a mix is a diameter. So M20 means the diameter is 20. Next thickness. Thickness is the plate thickness. The plate thickness is normally taken from 8 to 12 mm. Next FU. FU is the plate tensile strength. It's normally taken 410. So D naught is the diameter of bolt. D is the diameter of the bolt. E and P. E is the end distance, P is the pitch, T is the thickness of the connected plate, FUB is the bolt strength, FU is the plate strength. So this is the nominal strength, nominal bearing strength. So you go for safety purpose, you apply the partial safety factor gamma MP divided by nominal value divided by safety factor. So safety factor is page number 30 in our code book IS 800. You take the value 1.25 you taken for the safety factor. So apply the safety factor, the design strength is required, design bearing capacity is calculated. So which this purpose you resist the shear failure and bearing failure. The two strength is very important for the bolt connection. So these are the bolt strength. The next one is plate strength. Plate having three types of failure and three types of strength also you resist that. So first one is yielding strength. Yielding strength means this normally the area divided by partial safety factor. The formula is AGFI divided by gamma m naught. This is the yield strength formula. In your IS 800 2007 code book, page number 32. So AGFI divided by gamma m naught. This is the formula, yield strength formula. So AG means overall cross area. So plate strength. So these are threes are the plate strength related. The above two one is normally for bolt connection. So first one is yield. Yield is page number 32. You take that. Formula is AGFI divided by gamma m naught. AG means cross area. Cross area means the plate area. Plate having the length and the thickness. So the length multiplied by thickness is calculated for the area. Next FI. FI means yield strength. So the plate tensile strength 410 means yield strength normally mild strength ratio. So 250 you take that. Divided by gamma m naught. M naught also plate safety factor. So you take on 1.1 for your code book purpose, page number 30. So this is the rupture. So rupture is very important. Rupture failure means sorry, bolt and plate connections. The joint failures are occurred. So you go for the rupture strength is calculated. So rupture formula already 0.9 AN FU divided by gamma m naught. So AN is the net area. Net area having one formulas are here, page number 32. B minus N D naught into thickness. So N is the number of bolt. D naught also already you know that D naught is the diameter of hole. Thickness also plate thickness is required. So this is the rupture. So next one is black shear. Black shear is normally go for the angle section. The angle is the inclined member. So black shear is black shear failures are occurred for angle section. So angle consideration, the resist the black shear, you go for the black shear strength calculation. So first one is bolt strength, second one these are the plate strength. So this two strength is calculated. After that the efficiency is maintained. The efficiency of the joint, the bolt and plate are connected means the joint is created. The joint having the strength is the noted as the efficiency. So what is the efficiency formula means? The strength of bolt divided by strength of plate into 100. So efficiency is normally required for this connection, normally required for the steel member. So these are the basic things. You go for the steel structure consideration. This calculation is very important for two types. Normally you go for bolted connection, not using riveted or welded. Riveted is the skilled labor wanted, also mental being noise pollution. The noise, the bolt are inserted, very much noise is produced. So this one is rejected for this reason. Years the bolt connection is normally used. It is very easy to dismantle. Is normally temporary structures also used. The material savings also, the cost is very low, and high advantage having the connection is bolt one. So you go for steel structure means the bolt connection is must consider for this one. So these are the steel structure basic things for calculated. So the next bearing capacity, shearing capacity is very important. So thank you for all. Thank you.